Let us look at square roots. If I ask you to draw a line segment whose length is equal to square root of 2, would you be able to do it? It is not possible to draw a line segment whose length is equal to square root of 2 because square root of 2 is irrational. So we will have to use a process by which we can arrive at that line segment. We draw a line segment AB equal to 1 unit. Then we draw another line segment BC perpendicular to AB. And if we join AC, the length of AC will be what? This is 1, this is 1, this is a right angle. So by Pythagoras theorem, we know that AC will be equal to square root of AB square plus BC square. That is 1 square plus 1 square, the whole thing under a square root. So 1 square is 1, 1 square is 1, so 1 plus 1 is 2, so we have square root of 2. But what if we want it in a straight line to AB? What we do is we draw a circle with center A and radius as AC, so that we get now AD is equal to square root of 2. What about square root of 3? Square root of 4, square root of 5, square root of 6. Square root of 4 is okay. We know it is 2, so we can draw a line equal to 2 units. So let's see how we can arrive at the square roots of 3, 4, 5, 6 and so on. And we will look at it in a slightly interesting manner. So let me get rid of this D. Now remember, AC is square root of 2. So what I do is I draw a line perpendicular to AC at C and join A with the endpoint of this perpendicular line. Let's say it is G. So now square root of 2 square is 2. This is 1. So square root of 2 plus 1 is root 3. So AG is equal to root 3. Similarly, if I draw a line perpendicular to AG at G and join A with the endpoint of this perpendicular line and name it as H. So now here we have AG equal to root 3. This is 1. So root 3 square is 3 plus 1, 4. Square root of 4 is 2. And like this, we can arrive at various roots. Like this, we can arrive at a line segment which is having a length of root 2, root 3, root 4, root 5, root 6, root 7 and so on. Now if we want it on a line, we want to find this on this line, root 2, root 3, root 4. Root 2 we have already seen. So now let's see. How did we get this D? Because we drew a circle with center A and radius as AC. It would intersect at D. And since AC is root 2, AD will be root 2 as well. Similarly, we can arrive at equivalent points on the line. This is root 2, root 3, and these are the various points on that line. So that is arriving at a line segment equal to a square root. Interesting, yes? Now, What if AB is not 1? Remember, we started off with AB equal to 1 and BC equal to 1. If I make it 2, now try to arrive at what the values of these AG, AH, AI, AJ, AK are. Similarly, what would be the values if BC is equal to 2? Only whole numbers. What if it is somewhere in between? I would strongly suggest that you actually arrive at this figure and manipulate these lengths of AB and BC to figure out how it would impact the lengths of these various hypotenuses. That is plotting the line segment whose magnitude is equal to a square root number. That's it for now.